5 का है. उसको सेपरेट टू वन एरिया है. Okay, let's start, I think. Chapter 13 के अंदर. Okay, let's start. Yeah. Fine. So, let's start with the introduction of Java. Or before that, we can have our introductions. Only two of us. Yeah.
So I am Megha Jadhav. As you know, I did my BE from Rajasthan College of Engineering, and I have 3.5 years of experience with TCS, Putney, and network software.
Okay.
And last 3 years, I am doing nothing.
Fine. So,
Taking care of my baby. And I did Java 4 way back in 2007.
4 and 8 is very different. So, we'll see that. Yes.
I read something.
Yeah. Yeah. Okay. So since 2000. Fine. Okay, but we should have flair for programming. And so, yeah, I'm Praveen Jain. and, so,
Very famous personality.
okay, so let's proceed, I think, right? So let's start with the introduction of Java also. Okay. Yeah, I should have it. Fine. So, what is Java? Let's start with this question. The question is, yes, what is Java? Yeah. You would have heard already something about Java. So, what is Java?
Java is a language which
So, Java is name of a
language which gives platform.
programming language?
Yes.
Okay. So, one aspect is, yes, Java is a programming language. Okay.
Which gives the flexibility of independent platform.
Okay. So, you're saying it's a platform independent programming language?
Yes.
Programming language. Okay. It is platform independent.
It's case sensitive.
Case sensitive. Okay. It's a programming language. And languages will have these. Yeah.
It works purely on objects.
So it'll say object oriented. Okay, it's an object oriented programming language. Okay, which is also platform independent. What else is Java? What is Java?
Java is a coffee in Jakarta.
Java is a
Coffee.
oh, it's a coffee brand. Okay, yes, it's a coffee brand. Only coffee brand. There's something more.
In Jakarta.
Coffee. Java is name of a
Brand in Jakarta.
island.
Island.
Yeah, Indonesian island. It's name of an Indonesian island. See, you will find references Java, Sumatra. These two.
I don't know.
And
I know how Java has been named as a Java just because of this coffee.
and there's a language, spoken language.
Java.
Not, it's called Javanese, which is spoken by those people. Native language on the Java island. Okay, it's a native language. There's a script for them. Javanese. Yeah. What else is Java? So coming back to the serious part, Java as a programming language, Is Java just a programming language? This aspect is about programming language. Java is a programming language. What else is Java? Java is name of a programming language. That's what you have been saying. Okay. There's nothing more. You're only giving some features here. What else is Java? Java is, and one is it's a programming language. These are the various features of that language. Java is also name of a platform. Java is a platform. Fine. Java is also name of a platform. Okay, the two are separate. That is what one should remember. Fine. This is what is important to know. That Java is also name of a platform. Okay, see, we have got, for example, when we say Java is a programming language, we've got a Java language specification, JLS. This specification talks about Java as a programming language, the syntaxes of the language. Fine. The syntaxes, the various constructs available, find the correct way of writing any Java code. Okay, so that's what would be available in Java language specification. You can search for JLS, you'll find jls.pdf, you can download that. Fine, for various versions of Java language. Okay, and then when I talk of a platform, okay, Java is, as it is, it's a virtual platform. Okay, and therefore what we have here is there's another specification, just like we have a JLS, Java language specification, there's also a JVM specification, Java virtual machine specification. Fine, which will talk about the platform, the requirements of the platform. Okay, so two things are separate. One is a Java platform, other is a Java language. Okay, how the two are related?
JVM is a platform which converts, like whatever we write, it converts into the bit, and then that bit, based on the security, it will be executed. That's how Java is secured. Like JVM, Java Virtual Machine. That's what JVM does.
Okay, let's not talk about security and other things now, but okay, what's the relation between them? We have a platform, right? There are so many other platforms also. So what's special about the Java platform? What's anything to do with the Java language itself? Does Java language run on any platform?
Unless
No.
and until we have virtual machine.
So what, and what is that virtual machine? It's the Java platform. So the Java programming language, whatever you write in Java programming language is something which is designed to work on the Java platform. Fine, that's one thing we understand, right? But another thing is, Java is not the only programming language to work on the Java platform. Okay, we've got Java as a platform. Remember this, Java is a platform on which there are several programming languages which can work. It's not only the Java language. Of course, the Java language is designed to work only on the Java platform. It doesn't work on just any kind of a platform. Okay, so what other languages, some examples of languages other than the Java language which work on the Java platform? They work on Java platform? Available for Java platform? For Java platform? Okay, I'll give you some names.
JavaScript.
For Java platform, we are talking about Java platform. On the Java platform, you have things, you have heard of Python?
Yes.
There's something called Jython. We have Jython, which is nothing but the same syntax as Python to work on the top of Java platform. Okay, you have Ruby, or there's JRuby. You got JRuby. You would have heard probably of a language called Scala. Scala. Okay.
Scala, Python. Ruby, I heard about.
Okay. So JRuby. That's JRuby. That's Python. We even have something like another functional language, Clojure. And these are just some examples of many, many programming languages which are available on the Java platform. Clear one thing? Java is a platform, okay? And it's a virtual machine. Not yet. They're not available for the Java platform.
They are all for system deployments.
They are available on native platforms. Oh, Java platform is different. We'll see what is the relation between native platform and when we say Java platform. Oops. 1 second, it's me. Let me check the net connection. I didn't remember. It should have been on this. It should have been here. Should I switch now? I'll have to repeat probably. Oh, those things would have gone. Those things would have gone. If I reload, things will go away. It's not coming on its own. Reload, let me get reload. Okay, let's start. It has to. Okay, fine. Let me just write a couple of things. So it was about what is Java. Fine. So I'll just write the main points. Fine. One is Java is a programming language. And second main thing is it's a platform. Java is name of a platform. For this, we got a Java language specification, and thus we have the JVM specifications. Okay, you could search and download both the PDFs, and they are available openly. Okay, fine. And other thing was on this platform. Fine, we'll see. We found it's not that Java is the only language which works on the Java platform. There are other languages which work on the Java platform. Okay, now let's proceed and look at what exactly is. Okay, a few fine. Let's look at a few features which are being used related to the Java platform or the Java language. Fine. We'll say Java is a platform. Fine. Most commonly, the term used is it is platform independent. That's as soon as someone talks of Java, the first thing someone will say, oh, it's a platform independent language, right? Okay. So let's discuss about what exactly is the meaning of platform independence in case of Java. Okay, that's one thing. Okay. Another important thing is we'll discuss is related to what exactly made Java popular. What made Java popular?
This feature itself, platform independence.
it alone was not, there's some component which is available in Java which actually brought Java into limelight. It triggered the popularity for Java.
Object
No, there's something called, it's used on the web,
applets.
applets. Fine. So that's the next thing we'll be discussing. Okay, just a look at what exactly, how it was different from what was happening then, right? And third, we'll discuss is object-oriented programming. Fine, so that's what we are going to mainly discuss about. Okay. Okay, so let's see this. Right? So let's begin with the first point, which is about what does one understand by platform independence. When people say, oh, it's platform independent, what exactly is meant by platform independence? Okay, to understand this, let's look at other language like C and make a comparison between how do we write a code and then how do we compile and finally execute the code. Fine. In case of C language, what is done, and in case of Java language, how it is done. It's just a comparison, small comparison. So if we have a code in C language, how do you finally get it executed? The steps would be, oh, you got your code in C language, and that's your code. Okay, what would you do? Compile this. Okay, when we compile the code, the output of compilation would be some executable. Okay, this is because of you compile the code and you get an executable. Okay, and then next step.
Run the code.
Oh, this execute. What is an executable?
It will compile.
What is it made up of?
It's a binary
Binary code. But what does it contain?
executable
Instructions. Instructions in a machine language. Fine. Instructions which are according to a platform. Right? See, for example, if I take a C code, compile it on the Windows platform, the output of compilation is an executable which has instructions to work on the Windows platform. When the instructions come from an instruction set, that instruction set is nothing but the instruction set which is for the specific platform where you are compiling. Okay, so the output of compilation, this executable would work on a specific platform. Okay, and this is how it is. And that's the normal thing, right, for C language. Okay, let's compare this with what happens in case of Java. In case of Java, what exactly happens is, yes, you got your Java code, source code for Java. When we compile this, the output of compilation, yes, what is it? The output of compilation, we call it as, it's known as the Java bytecode. Okay, the output of compilation here is Java bytecode. And what is this Java bytecode? Yeah. What is the Java bytecode? Like executable?
binary code itself.
It's like executable. It's also binary code. Fine. Which is nothing but instructions. Instructions for
To run
a platform. Which platform? The Java platform. Fine. See the difference. You can see the difference. When you compile, Where you compile, accordingly the executable is created. Here you compile, wherever you compile, independent of where you compile, the output of compiler is the same. Given a particular Java code, the output of compiler is always the same. Because the target is not the native platform. The target, fine, the target of compiler is, it is targeting the Java platform. It's creating code to run on a Java platform. Okay, fine. So Java bytecode is nothing but instructions for the Java
So you
platform.
mean to say that in JRuby and Jython, all that languages, whenever you will compile,
Yeah,
it will be again a Java bytecode.
Java
That's why
bytecode. They all compile to Java bytecode. Yeah.
that is how
So any language which gives compilation to Java bytecode, yes, that's the one which is working on the Java platform.
how this executable file and how this
Yeah,
Java
yeah.
bytecodes
Now,
are
what is needed for the Java bytecode to run? So at runtime, what is needed is we need a JVM, fine, or we'll say JVM interpreter, which interprets and executes on a native platform. So running is done by the JVM interpreter. For execution part,
this
fine,
executable file and this Java bytecode. Both are again a binary code. Then how it is different?
this one,
Yes.
okay, I have compiled my code, then I don't need to give the source code. That's one thing. Fine.
Once I have compiled, I don't
Okay. Now this compiled code will work where?
in any JVM machine.
Any machine which has a JVM. That's it. What about this?
Here it will be source code.
It will work, the executable will work only on the machine where you compiled it, not on a different platform.
Okay.
Fine.
It's
You
a
have one
machine
layer, right?
independent or it's a
Yes,
machine
this
independent.
is giving us the independence. What we have here is for every native platform, find different types of native platform, we got a JVM interpreter. Okay. Fine, that's how the independence comes because of this layer. Okay, it's interpreted at runtime. Fine, we say it is interpreted at runtime. Fine, because it is interpreted, fine, it is supposed to be slow, right? Fine, but it's not that slow because of lots of efforts which have gone through, which it has gone through. Fine, this JVM interpreter has been, fine, the work here has been tremendous. What they have done is they've put in a lot of efforts and there are a lot of techniques used. Okay, one such thing is they use something called JIT compiler, just in time compiler. Fine, see, in case of interpretation, right, if you got a loop, how will the interpreter work? Fine, it interprets each time the loop. Here it realizes it's a loop. Let me compile this into native. It has to anyway compile into native each statement. But then when it finds it's a loop, okay, let me do it in one chunk. Right, something like that. Fine, we call it as a just-in-time compiler. Fine, for execution purpose, and that's how they have made it much faster. It's much faster and not slower. It used to be initial days. Yes, it was considered to be speed was one of the concerns when people were thinking about Java. Okay, but not so. Fine, that was up to 1.2 or something. But then
After 1.3, I did not heard about slow execution.
1.4 was a tremendous
Stick.
performance
But here it is
shift.
virtual machine, not in case of syntax errors. Not in case of much of syntax errors.
No. Okay, so lot of performance improvement was done in Java 1.4 as far as I/O was concerned, input output. When so clear, what is platform independence? Meaning of platform independence. Okay. Next thing let's look at is the use on the web. How Java was used on the web, the applet thing. Okay. To understand this, the use of applet. Okay. Let's first try to look at what is meaning of few things. What is internet? Try to understand this. Yeah. What is internet?
Internet is something which gathers the information from all over the world and provides it in one shot.
How? Okay. What do we use in internet? How do you use your internet? How? What do you need on your machine?
I need one extra from a button.
Browser. Okay. Right. What's browser? It's just a client for. It's a client. Then what's the other side?
Server.
Server. So what's internet? Now tell me.
It's a communication between client and server.
It's made of a lot of servers, right? Okay. It's nothing but it's having a lot of servers. Okay. Fine, which are available and they have a lot of content. Fine. We use a browser to ask for content. Okay, so let's see this how it's happening, right? So for that, let's take a typical browser. Okay, some typical browser. Yes, so if you have a browser, what do we do? So you got a browser, let's say. Fine. Or what do you key in here? What do you key in here? It's a browser. There's a bar in the browser. This. What do we key in?
Address bar.
We keep. What do we put? We call it as a.
URL.
And that's the input given to the browser. Browser program is a client program. Right? The user gives an input called the URL to the browser. Okay, let's look at a typical URL. A typical URL looks like http colon slash slash some domain name. Okay, so yeah, someone says www dot.
Let's say ibanking.com. ibanking.com.
You got iBanking. Okay, let's keep some simpler sites. Okay, fine. Let's google.com. It could be something else. Where then the next part would be something like slash,
And then let's
then
say
something dot HTML. Very common thing. Okay, fine. This is an input given to the browser. Fine. What is the input given to the browser? Oh, that's the input. Okay, when we give this input to the browser, how does the browser use this input? What it would do from this input is, it will look at this part first. Oh, what is this? What does this correspond to?
it's a server address.
Yeah, it means some server, right? Okay, it would resolve to some IP address. This will get resolved to an IP address. It knows that's a machine. Fine. Where
This is
what is supposed to be running?
.html.
Where a web server, a HTTP server is supposed to be running. Fine. It is assuming there is a HTTP server, and therefore what it does, okay, so let's assume this is nothing but our host, whatever. This is what we call as the host. So this is the host machine. This corresponds to a machine, right? Ultimately, this corresponds to a machine. Fine. This is identifying a machine. Fine. So we have said this machine. Fine. I want to follow. What is this? Protocol. Okay. So I would like you to follow HTTP protocol. Fine, you make a connection. So what the first thing it will do? Okay, identify this. On this, because you have not mentioned much other data, it will assume and will try to locate a process, which is nothing but our web server, or call it as the HTTP server. Okay, fine. So this browser makes a connection to this. Fine, like we make a phone call, right? Make a phone connection. It has made a connection. A communication channel has been created between the browser and the server. And then on this channel, what does the browser do? It uses the HTTP protocol, the syntax of the HTTP, fine, to send a request. And what is it sending? It is sending a HTTP request. Fine, it is sending a HTTP request. And what is the request he is making? He is saying, oh, you get me. This is the resource I am looking for. Maybe there's a directory name and slash something, fine, it could have been anything. So he's saying, oh, I'm looking for something dot HTML. Fine, that's a request which goes from the browser to the HTTP server. What does the HTTP server do when it receives such a request? Yeah, this server here, yeah, it will try to locate the content. When it tries to locate whatever is the resource you're asking for, that's our resource. So it tries to locate such a resource on the host machine, server. Fine, server here is referred as a host. Okay, on this host, it will look for this resource. Fine, if it finds such a resource, the content of that resource is going to be sent as a response back to the browser. Fine, the browser. What does the browser do with this content? What is it getting? All HTML. Fine, it is getting HTML. Okay, fine. So what is this browser? The browser is very versatile and understands the various HTML tags. It actually understands so many different types of content. Oh, it knows, oh, this is HTML, fine. I know how to display that HTML. It knows how to render various kinds of content. Fine. And most commonly, HTML content. Okay, I know, I understand all the HTML tags and I can show it to you. Fine, it starts rendering. Now, just see, as part of that HTML content, if it receives a tag, I'm putting one of the tags typically which may appear, a typical tag which could appear could be a tag called img, image src equal to, and something .gif file maybe, and the other attributes as well. So if such a tag is received by the browser, what does the browser do?
Browser, like this image that it understands that, okay,
Yeah.
I have got
What it has got is HTML tags, and one of the tags is like this.
then it will look for this GIF
Where?
file.
Where? Where is the GIF file?
It's coming as in
So what does it do? This tag is a resource tag again. It's another resource. Where would it be available? On the server. So it again makes a connection. Fine. Again makes a connection to the server and sends a request. What is the request? You get me so and so GIF file. Okay. Fine. What will the server do? Locate the GIF content. Fine. And send the content back as a response. Fine, it receives and it is able to render it. Yes, it's versatile, it understands content. Oh, I know this is GIF, I know how to render a GIF. Fine, browsers know how to render a image file. Okay, they can show an image file, they understand the tags, bold, italics, all those tags which are there in the HTML. Fine, they understand all of them. Okay, fine. So this is how it was, right? Oh, now the thing is, what I'm talking about applet is just a little history. This was way back. Java. Java was, when was Java created? The project for Java was started by Sun Microsystems, and which was taken over by Oracle, and which has been taken over by Oracle. Okay, so Sun Microsystems in 1991. That's the time when it was started, and it was initially called as Project Green. Okay, that's how it was initially initiated. So it's just to give an idea that the days when we are looking at when was this happening, when this applet, how it made a difference. Okay, so during those times, yes, that's how HTML was being used. That's how the internet was being used. Storage of content, static content all over the places. You would have images. Yes, you will have images. You'll have those images coming to the browser. Fine. Now, what was done by, okay, what was done by, so Sun Microsystems, what they did, okay, another one, yeah. This is Sun Microsystems, 1991. A few other things related to the history of Java. Important person here. Who's the scientist in Sun Microsystems? Who who led the project? James Gosling. Fine. He is referred as the father of Java. Right? James Gosling is referred as the father of Java. Okay, and it's an important name for Java. So what Sun Microsystems did, let's talk of this, and then we'll talk when they did this, fine, when it was done. Fine. They demonstrated something about applet. Now what, for demonstrating applet, what they did was, they said, oh, like we are having an image tag, let's add one more tag. And they added a new tag called applet, where you would specify code equal to and specify some file and specify something which would refer to a Java bytecode. It would refer to a Java bytecode. Fine. Of course, there are other attributes as well. Okay, just like we have the attributes for the image tag. Now, what happens? What they did was this: they modified. They did this with the Netscape. So, as a browser, they used Netscape Navigator. And because this was not part of a standard HTML, okay, so browser would not support the applet tag that time. But for demo purpose, yes, they updated the Netscape Navigator, fine, to make it understand the applet tag. And whenever, now what would happen? Whenever the browser here would receive an applet tag, fine, just like it was receiving an image tag, there was another resource tag called applet. When it receives an applet tag, what will it do? It will send a request. Just like it was requesting an image, now it is requesting Java bytecode. Clear? Where is the Java bytecode? It is on the server. The Java bytecode is stored on server, one place. Connect from anywhere. When open your page, open your web page. That web page contains an applet tag, would mean it goes to that server, gets your Java bytecode program. What is needed here by the browser? We say the browser needs to be Java enabled. What is meant by Java enabled here? Oh, it has a JVM interpreter. What's needed is a JVM interpreter. You have your Java bytecode, and it doesn't matter where is your browser. You might be using a browser on a Mac. You might be using the browser on Windows, on Linux, any platform. That platform independence of the Java bytecode is what plays a good role here. That makes a difference. See, just like GIF is a standard, right? It's a standard format. Oh, it doesn't matter whether Windows shows it or Linux shows. Fine. But a platform, they all understand GIF is GIF. Same way, your Java bytecode is Java bytecode. It's not. It's a code, but it's a compiled code, but it's not dependent on your platform. Fine. That platform should have a JVM interpreter. Fine. So you may be using your browser on any platform. Fine. And this is what was demonstrated on. This is what was demonstrated by Sun Microsystems on 23rd of May 1995. And therefore, this date is considered as the birth date for Java. That's what made Java popular basically. When they demonstrated this, that's when people started looking at the things. Oh, till that point of time, there was nothing like this happening. And this is a pioneering thing. Okay, having code stored on a server, and code comes to the client and executes within the browser of the client. Fine, clear? Executing within the browser of the client. So, Sun Microsystems were the first one to demonstrate such a thing, and that was the date. Okay, and this because of this applet, because of applet, Java became popular. Fine. Otherwise, yes, it was not being looked at by people. Oh, we already have so many languages, but then, so this, internet started. The usage of internet is around 1995 that it has picked up. Java also grew along with the internet. So many times people say, oh, Java is the language for internet. But no, Java is not the language for internet only. Fine. Java is a general purpose object oriented programming language. Fine. Java is a general purpose object oriented programming language. Fine, clear? This applet, the working part, right? Okay. Fine. So we have. Now let's look at this aspect. Okay, what do you mean understand by object oriented programming? Okay. And to understand this, what is object oriented programming? First, let's go towards basics. What do we understand by programming? What is programming?
It's a language made up of syntaxes, variables.
We have syntaxes, all those things as part of the language, but when I say what is programming? Yeah, what is programming? It is nothing but writing
Logics.
instructions. To do what? To solve a problem, we are writing instructions, right? We would like to write instructions which would solve a problem. Okay, what do these instructions do normally? What are these instructions like?
Can be anything like summation of something.
Okay,
Division of.
that means what they are doing? They are manipulating,
Yes.
or they are using
Inputs.
data. Okay, what is data? Instructions work on data. Okay, so we have instructions, we have data, and when we say data, what is data?
It can be anything.
Anything? Yeah, that's correct. It's anything.
It can be like image, it can be like any numbers,
Numbers. It can be text.
any text, any variables, and there's no limit of it.
Right? So,
It's an
oh, so
information.
yes, saying what we are trying to point out here is, oh, we have various types of data, right? Kinds of data. Fine, you're saying, oh, it could be image, it could be text, it could be numeric, and all those things. Okay, so we got two concepts here, and they are quite linked, right? We have a concept of instructions, or another name is operators. Yeah, operators. Fine, instructions are operators. Fine, you said add. Oh, so we have operators. Fine, it's that category. Fine, it shows an interaction basically. Fine, we'll see that. Okay, so we have operators on one side, and we got data types. Relation goes like this. Given a data type, fine, given a data type, I have some operators which will work on this data type. Oh, if this is the type, then these are the kind of operations which can be performed on that type. If it's numeric type, oh, I can do addition, subtraction, multiplication, division, modulus. I have n number of things. Fine. If it's an image, oh, I can do operations like taking a sub image, or fine, increasing the brightness, and there are various operations, because if this is the type, these are the operations which we can perform. It's all dependent on the type, what operations you should provide. What are the operators? Operations, operators, very synonymous. Fine. Okay. So, fine. Let's look at the progress of the programming languages. Fine. So, we got programming languages like, we started with low level languages like machine language and the assembly language. Fine. And the machine language and the assembly language, it was nothing but all instruction sets. And the instruction set had instructions where the operands would be there. Okay, if so, we had a fixed thing, or this instruction was available for certain types of operands. Fine. When you write your code in a lower level language, what are the data types I can use? Yeah, what are the data types which we can use? Oh, that's fixed by the language. We don't have more choice. It's fixed by the language. What are the operations that can be performed on those data types? Again, fixed by the language. The language has decided there's nothing else you can do about it. And both things were fixed by the language. Okay. When we came to a higher level language like C, okay, high level languages, procedural languages like C language, yeah, what happened to these two things? C language, for example, has provision of a programmer being able to create his own data type def, struct. When we have struct, where we can go for a structure. And you can create your own data types. So what we say, as far as data types in higher level language was concerned, fine, this are programmer defined as possible. Fine, programmer defined as possible. Whereas operators, oh, given this data type, what are the operations I have to perform? Even in a language like C, it's decided by the language. It's the language which has fixed it. So this is still fixed. But when we talk of object-oriented programming, yes, we got programmer-defined data types, fine. And on these data types, what are the operations which can be performed? Oh, you are creating a new data type of your own. Oh, in this data type, okay, on this data type, these are the kind of operations which I can perform, and therefore this is also programmer defined. We have the option here of operations also being programmer defined. So this is how the programming languages have been evolving. Clear with respect to data types and operators. Clear? Fine. The idea about object oriented programming is I'm not bound by the language. Oh, language has only given me so many data types. The language only gives me so many operators for each of those types. You don't find something, you find there's something. I think there should be a type like that. Okay, language doesn't have it, create it. When you create your type, you're not only thinking in terms of structure, you're also thinking in terms of the operations which can be performed with the type. That programmer defines, program is able to define that operations which can be performed on the data type, which he defines. Okay, so both things become programmer defined. That's what is the difference here. And so when we think of object-oriented programming, it's the first thing is about this. It's a new data type. It's about being able to create types, but types which are more complete in the sense that it's not only about a structure we are talking, we are also talking about operations also, not just the structure, behavior. Okay, fine. Now, another thing about object-oriented programming is object-oriented programming or object-oriented way of solving problem is closer to the real-world way of solving problems. It's much closer to the real-world way of solving problems. And in real world also, problems are solved by collaboration. In real world, we'll find problems are solved by collaboration. To understand this, yes, that there is collaboration to solve problems in real world and to associate it with object-oriented way of solving problems, fine. Let's take a simple problem from the real world. Okay, how it is being solved. Fine. So our problem here, a very simple problem here is, we want to send flowers to our friend who is in Kolkata. Okay, let's say we want to send flowers to our friend who is in Kolkata. So, yeah, how do we go about it? We are looking at interactions now. What are the various interactions which are taking place? You have to give instruction, right? Yeah, basically interacting or giving instruction, you're operating. Yeah, okay. So, yeah, how do we go about solving this problem? You have a friend in Calcutta and you want to send flowers. Okay.
Somebody who wants like some shopkeeper who have reference over there. I
Okay.
can go to that shopkeeper and
Yes.
ask for his reference.
Okay. So let's go do that. Let's do this. Okay. So what we do is, okay. So here, fine. You have to use some actual things, right? So let's say what we do here is we go to the JK florist. Fine. We got someone called JK florist. So we go to, that's our JK florist. Okay, and we interact with JK florist. What is the interaction you have?
I want to send a flower to this particular.
So your instruction is
Send a flower.
send flowers. Okay, send flowers. Yeah, when you say send flowers, what is the associated information you will supply? Okay, you want to give address and phone number of the friend where it is to be sent. Okay, so that information. Okay, what else? The kind of flowers to be sent. the quantity of such flowers? Okay, so fine. You have this message, you have your interaction with JK Florist. Send flowers, give the information associated with this. When you do this, what will JK Florist do? How does he go about solving this problem further? Oh, he got this instruction from you. So now what's his, how does he go about this? What does he do now? What does JK Florist do?
If florist will communicate the same message
He
to
looks at the name and address first.
yes.
Oh, this address is not a local address. Right? It's different, right? It's the same instruction someone else will also give. I want this, but that's a local one, but this is not a local one. So there's a difference. When it's not a local one, now what he does when he finds not a local one?
You send a request.
He refers to a diary. He has a diary where he manages city wise. Oh, this town, that's a contact person. This town, that's a contact person. So he has his own diary, right? He has a diary which he'll look up, and then he is able to manage a contact in Kolkata. Let's say we have some contact here in Kolkata. Let's call him as, so this guy is KK Florist. Okay, so now, yeah, he's found that there is some KK Florist. Now what's the next step he does?
You pass on all the
Now he interacts. JK Florist has an interaction with KK Florist. What is the interaction?
send flowers.
Send flowers, yes. He is interacting and saying send flowers. Specifies
Flower name.
the information which is related to sending flowers. Okay, fine. KK Florist receives this instruction. How does KK Florist proceed? Same way. First thing, look at the name and address. But here, oh, it's a local address. For him, it's a local address. So if it's a local address, okay, I can proceed further. I look at the type of flowers. Okay, so what KK Florist is doing is he's looking at the type of flowers and then says, oh, this type of flowers, oh, I have a flower producer who does them, who produces them. Fine. So he interacts with a flower producer. Okay, so here is our flower producer. Let's say some flower producer is there, and he interacts. What is the interaction with the flower producer?
I want this flowers and the quantity.
So he says, get flowers. When he says get flowers, he'll specify the quantity, the type of flowers and the quantity. Fine, he gets those flowers, right? He's got the name and address, he's got the flowers. Now what's the next step he'll do?
They will transport the same flowers to a friend, that particular person.
How? How does he get them?
By sending himself.
Oh, he will lose business because there is no one at his shop. So what he does is he interacts with a delivery boy. So there is some delivery boy, okay, and he has an interaction with the delivery boy. What is the interaction?
Send
When he's interacting with the delivery boy, not the information, I'm saying what's the instruction? What is the send flowers? Delivery boy is able to deliver anything. He says deliver. Right? It's a delivery boy. So the interaction will be, oh, deliver. And what will give? The name and address, the contact details, and the flowers. It could be any other thing. Fine. And what the delivery boy will do? He'll go and then deliver it to your friend. Okay. So in order to solve a problem, there's a lot of interaction which takes place. And it's done by collaboration. Then there's collaboration. Fine. Let's come to this first one. You went to JK Florist and said send flowers. He understood send flowers. Why? Why JK Florist could understand send flowers? You go to Mochi and say send flowers. Will he understand? No. Why does JK Florist understand? Send flowers. Huh? He understands because he is a florist. He is a florist. Florist will understand send flowers. Fine. See, JK Florist is a florist. He is of type florist. Class. What is JK Florist? What is florist? What's the relation between JK Florist and florist?
Florist is a
Class. And what is JK Florist?
it's a type.
Object. The instance of that class. What is KK Florist? Instance of the class. Clear? This is object, the actual thing with which you are interacting. But anything which you are interacting is of a particular type, is of a particular category. Fine. And that is what is a class. Class is nothing but a type, simply a data type. Fine. Okay, fine. And you can understand here, because it's a type called florist, it has a fixed set of interactions which can take place. Send flowers, oh, florist. Okay, if it is florist, these are the things which a florist should be able to understand. These are the interactions available for the type florist. You do interaction on objects. Objects are of a particular type, and the type decides what it should be. Nothing different from the earlier thing. You have the type called int. If anything is an int, you can do addition, subtraction, multiplication, division, modulus. If something is a boolean, I can do certain things. It's same. There's nothing new. Only thing is, the type is programmer defined. The operations are defined by the programmer. You identified the operation called send flowers from the real world. You have your abstraction. This is what we call as abstraction. You created an abstraction. By looking at things in the real world, you thought, okay, I should have a type like florist in which I should be keeping these things. Clear? Okay. Fine. So class and okay. Now coming more, fine. Let's talk of a few more things. One thing is we are now clear with class and object, the relation between class and object. Object is an instance of a class. Fine. That's a relation between them. Okay. Now another thing further. You went to JK Florist and said send flowers. Now you can also interact with JK Florist, which is related to the commercial aspect, saying, okay, because of the service, get me a bill. You can ask for a bill. That's another interaction you'll have. You'll ask for, okay, accept this payment. These kind of interactions, which are saying, get me a bill, accept a payment, these are the interactions which you will have even with Mochi. He is also giving some service. All those shopkeepers, it's an instruction which is understood by shopkeepers. Oh, but what is florist? Oh, florist is a shopkeeper. Fine. Our grocer, he's also a shopkeeper. Also, he understands these interactions. So we got actually a still bigger thing called shopkeeper. I'm going other way around. We got a shopkeeper. Right? A shopkeeper will understand certain things. And when we talk of JK florist, JK florist, we say he's a florist, but florists are shopkeepers. Fine. So florist will understand, any florist will also understand anything which is available for shopkeeper. We have interactions which are defined for a shopkeeper. Fine. So our JK florist is able to understand not only things which are meant for florist, but also for shopkeeper. Fine. Oh, you can go to JK florist and say, how are you? He understands, how are you? Not just because he is a florist, not just because he is a shopkeeper, but because he is a human. He is a human. All humans understand, how are you? And it's an interaction available for humans. What we are saying here is supertype subtype relations. Human is a supertype. Within humans, there is a specialization called shopkeeper. Whatever our interactions, whatever a human can understand is understood by shopkeeper. Fine. Whatever shopkeeper can understand is always understood by a florist. This is what is inheritance. Supertype, subtype. Fine. See, subtype has more functionality compared to the supertype because it inherits functionality from supertype and has additional functionality as well, can add more functionality. Clear? So when we talk of object oriented programming, it's about understanding supertypes and subtypes. And of course this concept was already there. You talk of int, you talk of a long. Long is a supertype, int is a subtype. With long, you can do certain operations, right? You can do certain operations which are available for long. But when I say int, of course, whatever you can do with a long can always be done with a int. Those operators are available for int. With int, you can do more things. Or you even have the increment decrement operator. In case of C language, you don't have them for long, but you'll have them for int. If someone writes a function and says, okay, oh, this function requires a long value, right? You can always pass an int and say, fine, because anything which is available for long, fine, how this function has been written, the function is using long for that variable. If I use a int, whatever I am doing for long is available for int, and therefore int could always be used. Supertype subtype relations are existing even with the earlier data types from the language. It's nothing new. Fine, inheritance was there. Inheritance is just about supertypes and subtypes. Fine, a subtype inherits operations from the supertype, can add more operations. Okay, fine, so that inheritance concept was existing. Yes, when we create a new data type, right, we can inherit from some existing already created data types. That ability is nothing but inheritance. So the object-oriented programming language allows you to create your own data types where you can derive from existing types also. Fine? Okay. So you had this, fine. Let's use those. What are the terms we have understood? inheritance. Okay, we have understood about what is a class, what is object, and when I was talking initially, abstraction. What is abstraction? It's a process by which you are actually identifying the types. Fine, you identified that there's something called florist. What operations must be available on florist? The process of identification. This is what is known as abstraction. Fine. Don't link it with the keyword like abstract. Okay, the concept abstraction is like this.
It's like wrapping something.
No, it's just like modeling. It's more closer to the. You create your own model from the real world. You have your abstraction. Fine, you think from the real world. Oh, you want to solve this problem, and you think about types, categories. If this category, if something is of this type, okay, this is what should be the operations available. You are doing that process, right? That is what is abstraction. Fine. Because of abstraction, you are actually being able to define classes. Fine, and put the methods in them. Okay. Fine. Then we have the inheritance. Then another thing which is to be supported is data encapsulation or data hiding. Okay, let's understand data encapsulation. In that real world example here, when we interacted with J.K. Florist, we said send flowers. What did he do? How did he begin?
We looked for the instruction and then looked for his diary.
He looked into a diary, right? That diary, is it available to us?
No,
If it was available to all, what would happen?
we would have contacted directly.
Okay, what else? That's not as dangerous. There's something still more dangerous.
We would have not owned the one.
If the diary is available to all, fine. The read part is not that dangerous. It's about, you're talking about reading from the data from there.
Yeah.
You can read the data, that's good. Okay. Sometimes you might even ask, okay, do you know someone there? And he might oblige you and say, okay, fine, I'll tell you the name. And he might give you the name. That's okay. But what's more dangerous is if the diary, anyone can go and make any entries in that diary because it's openly available. No, we don't like that, right? Then the sanctity of the diary is lost. Who knows who has done what, whether those entries have to be believed or not, right? Clear? So we find in real world we never have, find we always have our personal thing. That diary he won't share. Right? He might share information from there, but no, might not give you. So you can say you can interact and get information out of the diary by interacting with him. Okay, so you have your data structures. Diaries are data structures. You have your data structures which are encapsulated. Fine, you have to interact with the object in order to get the information from the structure. Okay, fine, that's what the data encapsulation is about. Fine. Here's your data structure. It is encapsulated by code. Have your interactions, have some instructions. Say, okay, you get me this, fine. You say, okay, you can make this entry, he'll verify and then put the entry. But you can't make the entry directly. Fine, you can ask him to make an entry, he'll verify the things and then, okay, how reliable you are to him, fine, how much he trusts you, fine, all such things will happen, right, in real world. But no, he'll not give his diary to you.
That's called data encapsulation.
That's data encapsulation, right? Real world also data encapsulation exists. Fine. And then one more thing, from object-oriented programming point of view, we have is the polymorphism. Yeah, what is polymorphism?
More one name
Okay, there are many types of polymorphism. From programming point of view, there are two terms more popular. Okay, for polymorphism, there are two terms which are more popular. One is overloading, and other is overriding. So these are different types of polymorphism. Okay, these provide different types of polymorphism. Okay, overloading. Okay, let's consider overloading. Both have to be considered. Fine. So when we look at overloading, yeah, example for fine, a simple example for overloading can be like this. Let's consider that we have a plotter here. Fine, there is a plotter object. Fine, the interaction with the plotter. What is the interaction with the plotter? You can ask it to plot various kinds of things. It will go and plot the things, right? So your interaction can be, you can say draw a line. When I say draw a line, I'll specify the starting point and the ending point, 2 points. It goes and draws a line. Then someone says draw a circle. Fine. So when someone wants to say draw a circle, yeah, what would he give?
Radius and diameter.
Okay, he gives a center point and a radius. Okay, so when he gives the center point and radius, fine, this can go and draw a circle. Fine. Now someone else has 3 points in a plane, and we know there's a unique circle which goes through 3 points in a plane. So when someone has 3 points in a plane, what he might have to do now in order to interact with the plotter is he'll have to compute from the 3 points, he'll have to make a computation of center point and radius, and which is a very standard way, right? There's a standard mechanism of, oh, given 3 points, how to compute center point and radius. And suppose if he makes a mistake in that, he'll still blame the plotter. That plotter is not correct. And it may be his mistake, right? So, no, what we can have here is we can have one place to have mistakes rather than everyone having possibility for everyone to make mistakes. Okay, so that it can be corrected at one place. Okay, it's not that we are saying, oh, there can't be mistakes. Okay, so what we have here is we can add another draw circle which takes 3 inputs, 3 points in a plane. So given 3 points in a plane, I'll be computing it and I'll be using that draw circle. You can work by just giving me the 3 points. I'll take care of the computation part. Fine. So there are two different ways of doing a draw circle, two different sets of inputs. Fine. Fine. So this is what overloading is. Fine. The overloading is something related to this. And then if we talk of overriding, for overriding, at this moment, not a very great example, but just conceptually if you want to understand. Okay, let's continue with that same example of florist. Now, we can have an interaction with florist. All humans understand, how are you? Fine. But then when you go to a shopkeeper and say, how are you? Okay, what he might do is he might be extra friendly. See, there is a normal behavior for all humans. For humans, if someone says, how are you? This is how he's supposed to work. He's how he's supposed to respond. That's one normal thing, right? But when we do it for a shopkeeper, the shopkeeper becomes extra friendly, keeping in mind that, oh, he is a probable customer who will be coming to me. Fine, wants to be extra friendly. Okay, fine. So what is happening here? It's the same interaction called how are you, which was available for the supertype. The subtype is doing it differently. Same interaction, but he does it differently. This is what is overriding. Exception to the rule. All humans, that's one normal thing. But in this special case, this thing has to be done differently. It's an exception to the rule. Clear? Okay, so fine. So this is about polymorphism. Fine. Overloading, overriding. Fine. So object oriented programming. Fine. We understand what is object oriented programming.
This was overloading.
Overloading was this draw circle thing, right? Okay. Overriding will be having later on as we use, we'll have more examples, right? Okay. And so any questions now? Yeah. Clear? Okay. Fine. So we'll continue next time, I think. And next time we'll be continuing and we'll have a look at the hello world. How do we compile? How do we execute a Java application? What actually goes in a Java file? Right? Okay. And so that we'll look at in the next session. That will be on Wednesday. Fine, Wednesday we'll have next session. Okay.